Hello and welcome to Physics with Amol sir. So this video is for class 12 and we will continue with our chapter Electrostatic Potential and Capacitance. This is part 3. In the previous video we saw one very important derivation. Okay, that was for electrostatic potential due to a dipole. From exam point of view, that derivation is very important. Today we are going to see the principle of superposition. Okay, or we are going to talk about the electrostatic potential due to a system of charges, and then we will see one numerical also on that. So in the exam, some 2 mark or even 3 mark numericals can be asked based on to find out electrostatic potential due to 2 or 3 charges. Okay, so let's begin. So let us see how we can find potential due to a system of charges. We will start with 3 charges first. Let us say there are 3 charges, Q1, Q2 and Q3. Okay, these are our 3 charges. There is a point P. The task is to find out electrostatic potential at P because of Q1, Q2 and Q3. To do that, first let us make the position vectors. We will make a position vector from P going towards Q1. Let us call that as R1P. Then from P to Q2, let us call that as R2P. Then towards Q3, we will call that as R3P. Okay, so this is the situation and our task is to find out the potential that is going to develop at point P. Right, so that is the situation. Now to find out electrostatic potential at point P, we are going to consider first the potentials due to the individual charges. The principle of superposition will say that electrostatic potential at P will be the sum of potentials due to all the 3 charges, okay, or n number of charges. So now because of charge Q1, the potential at P, let us call that as V1. V1 is going to be 1 by 4 pi epsilon naught Q1 by R1P. R1P you can see that is the vector going from P to Q1. Similarly, potential at point P due to Q2, let us call that as V2, will be equal to 1 by 4 pi epsilon naught Q2 by R2P. Okay, similarly, potential at P due to Q3 will be V3, which is equal to 1 by 4 pi epsilon naught Q3 by R3P. Okay, these are the individual potentials. The total potential at point P, let us call that as V. V is going to be V1 plus V2 plus V3. And then we simply add all of them up. If we add them up, we will get 1 by 4 pi epsilon naught in bracket Q1 upon R1P plus Q2 upon R2P plus Q3 upon R3P. This is for 3 charges. If we are having n number of charges, this will go on plus Q4 by R4P plus Q5 by R5P up till Qn. Remember, if any of these charges is negative, for example, okay, for example Q2 is a minus charge, then what will happen in this particular derivation where we have written plus Q2, that will write as minus Q2. Getting the idea? But the total electrostatic potential is nothing but the total algebraic sum of all the electrostatic potentials. Okay, I hope that is clear. And this particular equation we are going to use in the next numerical that we are going to do. Okay, so I hope this is understood. Okay, now we are going to see a very important numerical. We are going to see a solved example from the textbook, which is example number 2.2, which you should be seeing on the screen right now. Okay, such kind of examples will be asked in the exam. Okay, so it is important that we understand them. Okay, so first let us read the question. Now I want you to read it very carefully. Read it 2 times before you are solving the question. So 2 charges, 3 into 10 to the power minus 8 coulomb and minus 2 into 10 to the power minus 8 coulomb are located 15 centimeter apart. At what point on the line joining the 2 charges is the electric potential 0? Take the potential at infinity to be 0. Okay, so I hope you have read the question. Now as you can see in the question, there are two charges. Okay, one charge is 3 into 10 to the power minus 8 coulomb, that is at the point O. The other charge is minus 2 into 10 to the power minus 8 coulomb, which is at the point A. Whenever you are solving questions like this, the first thing is to choose the origin. We are going to take origin at the positive charge. Okay. Now you will ask, can we take it at A? Yes, you can. Okay. You will ask, can we take it on any other point? Definitely you can. But whenever you are choosing the origin, it should be a convenient point. The most convenient point is our positive charge. Okay. So it is always a good idea to start from there. So O is going to be our origin. Okay. The line joining O to A, that will be our x-axis. Okay. The task is to find a point on this line. Okay. Not necessarily between O to A. Okay. It can be along this line. It can go towards left of O and towards the right of A as well. We want to find a point on this line where electrostatic potential is 0, and we are assuming there is no other charge in the vicinity. Okay. Now why will the potential be 0? You can see the charge O is going to create a positive potential. The charge at A is going to create a negative potential. So there should be a point technically, theoretically, where the potential should be 0, where they will cancel each other out. Positive potential of one and the negative potential of the other. Next thing to remember, the point where the potential is going to be 0, okay, will be along this line. To find any other is not possible. Okay, so we have to find the point where it is on the line only. Next now, where do we take the point? Should the point be towards the left of O? Should it be between O and A, or should it be after A? First, it can never be towards the left hand side of O, that is along the negative x-axis. Why is that? If it is along the negative x-axis, then you will see that if, let us say, this is our required point P, okay, which is towards the negative x-axis, then from O there will be a negative electrostatic field at P, and plus there will be negative field due to A. Okay, that is going to cancel it out, so we will not get 0 potential at P. Okay, so required point, it cannot be towards the left hand side of O, that is along the negative x-axis. So now let us start with assuming it is somewhere between O to A. Okay, that is our initial assumption. So we are going to consider that the required point where the electrostatic potential is 0 lies between O and A. Let us call that point as P, and let P be at a distance of x from the origin. X has got to be positive. Remember, x cannot be negative in this case. Okay, so OP is x. Thereby you can see that distance of P from A is going to be 15 minus x. Why 15 minus x? Because O to A is 15 centimeters. For questions like this, we need not convert it into the SI units. Okay, because we want the absolute values anyways. So we have assumed that the point P is such that electrostatic potential at P is equal to 0, which means that the sum of potential due to O and due to A is exactly 0. So let us say the potential due to the plus charge is equal to V1. V1 will be 1 by 4 pi epsilon naught Q1 upon R. How much is Q1? It is 3 into 10 to the power minus 8 upon, how much is R? It is equal to X. Right? Let us assume that at point P, the potential due to A is equal to V2. Then V2 will be 1 upon 4 pi epsilon naught Q2. How much is Q2? Minus 2 into 10 to the power minus 8 divided by R. How much is R? 15 minus X. Okay. So total potential at P has got to be 0. Thereby we should get V1 plus V2 is equal to 0. Right? So we can write V1 plus V2 is equal to 0. Therefore, then we take these two equations. 3 into 10 to the power minus 8 upon 4 pi epsilon naught x minus, because of this, 2 into 10 to the power minus 8 upon 4 pi epsilon naught 15 minus x is equal to 0. We can take this 4 pi epsilon naught common, send it there and it will get cancelled out. Okay. Then what we are left with? We are left with 3 into 10 to the power minus 8 upon x minus 2 into 10 to the power minus 8 upon 15 minus x is equal to 0. Okay. And now we can solve for x. Okay. I hope you can solve it very easily. Do the cross multiplication, solve for x. You will see that you get the value of x is equal to 9 centimeters. Okay. How to get this value? I think you are very well aware of the algebraic manipulation that you have to do for this. Okay. Do the cross multiplication and very easily you will get the value for x. So this gives us the distance of point P from O, which is equal to 9 centimeters. Next thing to remember, x or P doesn't have to be between O and A. There is a point after A where it can be 0 as well. Okay, so we can actually assume that P, instead of it being between O to A, actually lies towards the right hand side of A. Let us say somewhere over here, this is where the point P lies. Okay, and then we can measure the electrostatic potential at P, that is the distance. So we can say distance from O to P is again x. So thereby we will get V1 as the same as before. But V2 in this case will become minus 2 into 10 to the power minus 8, 4 by epsilon naught, but now it will be 15 plus x instead of being 15 minus x. Okay, and similarly you can solve for this. Okay, again assume that V1 plus V2 is equal to 0. Okay, and you can solve it. This time you will get x is equal to 45 centimeters. Okay, so this shows that at a distance of 9 centimeters from O, the potential is 0, and at a distance of 45 centimeters from O, the distance, the electrostatic potential is 0. Okay, I hope it is understood. Once again, as I said, go through the question one more time. Okay, we are seeing a question like this for the first time maybe, so it might be a little confusing, but these are very important questions. Questions like this will definitely be asked in the exam. Okay, so make sure that you understand this. Okay, so I hope that question was understood. Let us see the second one. This is example number 2.3 that again now you are seeing on your screen. So here we are seeing two diagrams. Okay, we have to observe the diagrams and then solve the questions that are given. Okay, so here you see them. First diagram is about a positive charge. So there is a positive charge. These lines denote the electric field due to the positive charge. And there are 2 points you will see, point P and point Q. Second diagram is for a negative charge. There is a negative charge. These are the electric field lines. Okay, and here you have 2 points A and B. Task is, now let us see the first question. Give the signs of potential difference Vp minus Vq and then Vb minus Va. Let us do it for this first. Vp minus Vq. Now, how do we find Vp minus Vq? Now, we don't have to find a numerical value. We simply have to give the sign, whether it is positive or whether it is negative. How do we understand that? Now, take a look here. This is a positive charge. Okay. What we understand about positive charge and negative charge is, very near to the positive charge, electrostatic potential is higher. Okay. Once again, very near to the positive charge, potential is higher. As you move away from the charge, potential will become lower. Okay. Opposite thing is true for the negative charge. For a negative charge, very near to the negative charge, electrostatic potential is lower, and away from the negative charge, the electrostatic potential is higher. Will you remember this? So for negative charge, if you are very close, that means the potential has gone down, and if you are very far away, potential has increased. And opposite case for positive. Remember these two things. Now, when you want to find out Vp minus Vq, correct? You have to find out what will be the sign. How do we understand that? You can see P is closer to the positive charge, right? Therefore, potential at P will be higher than potential at Q, right? So Vp will be greater than Vq in this case because P is closer. So higher potential, Q is farther, lower potential. So Vp minus Vq will definitely be positive. That is, it will be greater than 0. Understanding? Second case, we want to find out what is Vb minus Va. So for Vb minus Va, you will do the same logic once again. You will see A. A is nearer to the negative charge. So potential at A is going to be lower. B is farther away, potential at B is going to be higher. So in this case, Vb is greater than Va and thereby Vb minus Va again is going to be greater than 0. That is positive. So for A, both the answers are going to be positive. Okay, signs of both. Next is, give the sign of the potential energy difference of small negative charge between the points Q and P, A and B. Okay, now we have to give the sign of the potential energy difference of a small negative charge. Now this is different. This is not for a positive charge, this is for a negative charge. Okay, because it is a negative charge, then you are going to see that the difference between Q to P is going to be positive. Okay, negative charge, as it moves from Q to P, the energy will go on decreasing because it is a negative charge, so it is going to be attracted to the positive charge. So from Q to P, it is going to be positive. Okay. Okay. For the next part, the negative charge moves from A to B. Since it is moving from A to B, correct, it is going to face repulsion. So it is going to go from a higher potential energy to lower potential energy. So once again, the potential energy from A to B will be positive. Okay, because you go from a higher energy to a lower energy. So therefore, in both the cases, it is going to be, the difference is going to be positive. Third, give the sign of the work done by the field in moving a small positive charge from Q to P. So in moving a small positive charge from Q to P, work has to be done by the external agency against the electric field. Therefore, work done by the field is negative. So when you want to move a positive charge from Q to P, you will realize you will have to give a force, right? Because the positive charge will get repulsed by the positive charge, the positive source charge. So work has to be done on that charge. Because extra work is done from the external force, work done by the field is going to be negative. Okay, the external force does positive work, but the field does negative work. Fourth one, D. Give the sign of the work done by external agency in moving small negative charge from B to A. This is for external agency. Please remember to read the questions. Okay, so by external agency moving it from B to A. If it is a negative charge, you have to do extra work, so thereby it will be positive. Okay, so the external agency will do positive work, but the field itself will do negative work. Okay, then let us see fifth one. Does the kinetic energy of small negative charge increase or decrease in going from B to A? So if there is a small negative charge at B, okay, you will see that it is going to face repulsion. Okay, therefore the kinetic energy is going to decrease when it goes from B to A. Okay, if the question had been asked about positive charge, then from B to A the kinetic energy would have increased, but since it is a negative charge, the kinetic energy would decrease. Okay, this is a theory question. In exam, such questions can also be asked, and now because we are having multiple choice questions, there is a big chance that such questions are asked for the MCQs. Okay, so you have to make sure that you understand these kind of questions. So both these questions and the topic that we did before this, I am expecting that you are going to read through them. Okay, understand them thoroughly. Okay, in the next class I will be giving some more assignment questions. But first what I want is, I want you to go through them and be very confident that you can solve them properly. Then we will see more such questions. Okay, thank you.